Hello to Algebra Honors. Friends, this is Unit 7, Day 6. This is our second video. So we already did factoring trinomials. We started with our Part 2 lesson, and we've done factoring by grouping. So in this video, it's the second part of these notes. We're going to start by factoring our trinomials using the box method. Okay, so when we use our box method, we're going to have a box like the grid that you end up with if you are multiplying two binomials together and you're using the box method. But we start by putting our answer inside the grid, and then we're going to pull out the two binomials we started with. So when you're using the box method, you're still going to think about having your standard form ax squared plus bx plus c, or minus c, or whatever it ends up being. Okay, we're going to put that whole first term, ax squared, the whole term, including the variables, in our top left box, and we're going to put the whole constant in our bottom right box. Then we have to figure out our middle term. Okay, so I'm not going to put bx in there twice. I'm actually going to find my magic numbers and split up bx. So we could even be thinking this b1x and b2x. So we're going to split up our b and figure out what goes in those boxes. Okay, then we're going to pull the greatest common factor from each column and from each row, and so you'll see how that answer pulls out. All right, I'm going to start on this and then we'll come back and look at our helpful hints. Okay, so if I want to factor this, first I look for a greatest common factor. There is not one, that's good. And I'm going to have to use my X puzzle to find my magic middle numbers, right? So I'm going to say A is 2, B is -3, C is -20, A times C is -40. So I want to know two numbers that multiply to give me -40, but they add together to give me -3. One has to be positive, one has to be negative, right? For sure, to get a negative product. And so I'm going to say that that must be +5 and -8. 5 times -8 is -40, 5 minus 8 is -3. All right, so remember I told you top left, we're going to just plunk in our first term, the whole term. So I'm going to plunk in 2x squared. Bottom right is going to be that last constant term, and don't lose your negatives, okay? So that's -20. I just figured out my magic numbers for that center term. I'm going to break it into 5x and -8x. Now, I promise that if you put -8x here and 5x there, you will end up with the same binomials in the end, okay? So no worries if that's how you wrote it. Vertically, I'm looking down, and I'm going to try to pick out a greatest common factor looking straight down. So 2x squared and 5x, I can pull an x out. Looking down into -8x and -20, I'm going to pull a -4. Now, if you are looking into the very first box that you are touching and looking for a factor, if you are looking into a negative, you have to pull a negative out, okay? Here I was looking into a positive, so I had to pull a positive out. I'm going to do my rows now, so looking at this row, 2x squared minus 8x, the thing that I can pull out is 2x. It's positive because I look into this immediate box that's touching me right now, and it's positive. I don't care that the second term is negative, okay? I only care about what I'm touching. So 5x minus 20, the only thing I can pull out here is 5. And again, it's positive because what I'm pulling from first is a positive box. Okay, these are my binomials. Let's check it out and see if it works. I have 2x plus 5 times x minus 4. And we're going to check because it's just seconds. 2x times x is 2x squared. Outer is -8x, inner is +5x, and last is -20. And when I simplify 2x squared minus 3x minus 20, that, hooray, should match. 2x squared minus 3x minus 20. It works. Check. Whoops, I'm sorry. That's not my answer, though. That's just checking it. Let's pretend I didn't box that. This is my answer. These are my factored binomials. Pretend I didn't put a big box around that. All right, you can use this box method to factor even if your leading coefficient is 1. It does work. It's just probably a little excessive extra work for leading coefficient 1. Let's check this problem. We know A is 3, B is 11, C is -4, and so A times C is -12. So what numbers multiply to give me -12, but add to give me 11? It's going to be 12 and -1, right? 12 times -1 is -12. 12 minus 1 is 11. So remember, we put our whole first term in this top left box, 3x squared, my whole last term in the bottom box. And I fill these others with my magic numbers. So I have 12x and negative x. Okay, you know that if I wanted to rewrite this, to do it by grouping, it would be 3x squared plus 12x minus 4, right? So these are the two terms that I've just put in my diagonals there. Okay, looking down, I'm going to pull out 3x here. 3x goes into 3x squared and 12x. Looking down here, it has to be a negative because I'm looking into a negative box. But the only thing I can pull is -1, right? Left to right, the only thing I can get out of there is an x. I need a positive x because the box that I'm touching is positive. And here, 12x and -4, I can pull 4 out of those. So this should be my answer, 3x minus 1 times x plus 4. That should be my answer. Let's double check it though. 3x times x is 3x squared. Outer is 12x minus x, so I have 11x as my center, and then -1 times 4 is -4. I'm double checking with the original 3x squared plus 11x minus 4. Check. Okay, I'm going to just remind you, if you ever do the box method and when you check it, it doesn't work, even though you are sure you did absolutely everything right, the number one reason that happens is if there was a common factor that you could take out in the very beginning. So if you're ever checking your work and no matter what you do, it just doesn't quite work out, it's really close, but it's not quite right, go back to the beginning and make sure there wasn't a common factor to pull. All right. So just like last class and last several classes, sometimes we get polynomials that are just not factorable, okay? And so you call them prime. So sneak preview, these are both going to be prime. Here I know A is 3, B is 8, C is -5, and so AC is -15. I need two numbers that multiply to give me -15, but they add up to give me 8. And I look at that and I think, well, 3 times 5 is 15 and 3 plus 5 is 8. But remember, we need one positive, one negative. Okay, so if I'm struggling and I can't figure it out just by looking, sometimes I'll write out -15 and I'm thinking of all the factors. I know it could be -1 times 15, but when I add those, I get 14, so that's not it. I know it can be 1 and -15, right? But when I add those, I get -14, so that's not it. I know it can be 3 and -5. But when I add those, I get -2. Nope. If I do -3 and +5, I get 5 minus 3 is 2. Also not what I'm looking for. I'm looking for 8. There's no other factors of 15. There's no other way to do this. And so we just know this one is prime. Okay, we don't even have to try to do a box. We know that we can't pull out a greatest common factor. We know that we can't find those magic numbers in the center. Okay, so 5x squared minus 7x plus 3. I know again, I need two numbers, 5 times 3, two numbers that multiply to give me 15, but when I add them, they give me -7. We just did, oh, it's going to be positive 15 though, but we just did all of our factors of 15, right? So I know 15 is 1 times 15. If I add 1 and 15, I'm going to get 16. If I multiply -1 times -15, I'm going to get -16. Both not what I want. I want -7. So if I do -3 times -5, that's positive 15, but added together it's -8. And that doesn't work. So if I do +3 times +5 to get 15, and then add them, I get 8. So again, doesn't work, so we just say prime. Okay. Always look for a greatest common factor. So we will remind you usually at the beginning of a quiz or a test, but not for specific problems once we're testing you. So just always plan to do that. If you notice that your leading coefficient is not 1, take a look. Is there a greatest common factor? Okay. Then you have to remember that factor is part of your answer, so don't lose it, okay? So 12p squared plus 20p minus 8, I'm going to pull out a 4. Okay, so I have 4 on the outside. I'm left with 3p squared plus 5p minus 2. So now I am just going to be factoring out, I'm looking for a different colored ink. I'm just going to be factoring that trinomial, but I don't want to forget, where are all of my pens? I guess I'm using this one. I don't want to forget this 4, okay? So don't forget that 4. That is part of the answer. But we're just going to factor this trinomial. It has a leading coefficient that's not 1, so I'm probably going to use the box method, but you could use the grouping method. It doesn't matter, okay? I'm going to use the box method here just because we're practicing that. So I know A is 3, B is 5, and C is -2. Just for this trinomial, that's what I'm factoring now, not the original problem, right? Okay, AC is -6. So I need two numbers that multiply to give me -6, but they have to add to give me 5. So 3 times 2, -3 times 2 would be -6, but when I add them, it's not 5. I'm going to try 6 times -1. 6 times -1 is -6. 6 minus 1 is 5. So remember, with our box, coming back to, I'm going to use my red pen. With my box, and remember, we are just doing this trinomial right now, just this trinomial. I'm going to plunk my first term, 3p squared there, and I'm going to plunk my last term there. Then I'm going to use my magic numbers here. I have 6x and I have -x, right? 6x minus x is 5x. Crime and nutley. I'm going to say p because that's the variable we're using. My bad. Sorry. Looking down, I can take 3p from 3p squared and from 6p. And looking down, I'm going to take just -1 out of these guys. Left to right, I have 3p squared minus p. I can pull a p. It's going to be positive because I'm touching positive. 6p minus 2, I'm going to pull out 2. So my two binomials just for this trinomial should be p plus 2 times 3p minus 1. Okay, p times 3p is 3p squared. Outer is -p, inner is 6p, so that leaves me with 5p. 2 times -1 is -2, okay? I know this binomial matches that trinomial, okay? But here's my answer. My final answer is 4, because I don't want to forget my 4. 4 times p plus 2 times 3p minus 1. Okay, that's my final answer. So be careful when you're pulling a greatest common factor. Don't lose it, okay? Also, when you pulled the greatest common factor, you do, now that you have all these skills, you want to double check if you can factor out that trinomial, you want to do it, okay? So you want to go all the way as simplified as you can do. To check your work, you would multiply those two binomials together, which we did, we confirmed, and then you would distribute 4 times 3p squared, you get 12p squared, 4 times 5p, you get 20p, and 4 times -2, you get -8. Okay, so we're going to do this with 6y squared plus 57y plus 72. I'm going to pull, can I take a 6 out of all of these? Or is it just a 3? 6 goes into, no. Okay, it's going to be a 3 then. So we're going to say 3 times 2y squared. 3 goes into 57, 19y plus 24. All right. So I am going to hold off on this 3, but I know it's going to be part of the answer. So if you want to, you can even write, you know that you're going to hopefully have two binomials, right? So you can write this in anticipation of what you're going to get as your two binomials. You just don't forget that 3, okay? That 3 will be very sad if you forget it. I am now going to only factor this trinomial, okay? Only this trinomial. So we're ignoring the 3 for right now because we've got 3 up in our answer already. When I want to factor that, I know A is 2, B is 19, and C is 24. AC is then 48. So what two numbers multiply to give me 48, but add together to give me 19? And when I think that one through, it's going to be 3 times 16 gives me 48, and 3 plus 16 is 19. So here's my box. Okay, I'm going to plunk in my first term. Remember, we're only doing this new trinomial that we pulled out, okay? So we're not working with our original trinomial right this second. So I'm going to plug 2y squared in the top left and 24 in the bottom right. I know my magic numbers are 3 and 16, so I'm going to put 3y. Look at me remembering the right variable. And I'm going to put 16y. Okay, looking down, I can just pull a y out of those guys. Looking down here, I can pull an 8. Left to right, I can get a 2y out of those guys, and left to right, I can get 3. So my two binomials should be y plus 8, 2y plus 3. Okay, I'm pretty sure that works, but I'm going to just double check. Okay, so when I check, I want to make sure y times 2y is 2y squared, right? Outer is 3y, inner is 16y, and so when I add those, it's 19y, and 8 times 3 is 24, so that's true, right? That's the trinomial I expected. And then if I distribute this 3 times 2y squared is 6y squared, 3 times 19y is 57y, and 3 times 24 is 72, so that worked. I double checked it. Okay, you can practice these. You can pause the video and try these on your own and come back and check, or if you're feeling frustrated, keep watching and walk through a couple more of these before you try them on your own. Okay, every time I look for a greatest common factor, I don't see one here, so I'm going to say A is 5, B is negative 18, and C is 9. A times C is 45. So I want two numbers that multiply to give me 45, but they add up to give me negative 18. It has to be a negative times a negative, right? Because that's the only way to get a positive product, but add them together and have a negative. So luckily, this one's pretty easy. Negative 3 times negative 15 is positive 45, and when I add those two, I get negative 18. So I know my magic numbers, right? I'm going to put 5x squared. Can you see this? Yes. 5x squared in the top left, and I'm going to put 9 in the bottom right. And then negative 3x and negative 15x. Okay, now top to bottom, I get to pull an x. Top to bottom, I'm going to pull 3. I have to take a negative 3 though, right? If I'm looking into the box and I see a negative, I have to get a negative out. 5x squared minus 15x. This time I'm just taking 5x because the box I'm touching is positive. Negative 3x and 9, I can pull a negative 3. I'm touching a negative, so I have to pull a negative. So this one, my answer should just be x minus 3 times 5x minus 3. Okay, that should be my answer. I will double check it. And I have x times 5x is 5x squared. Outer is negative 3x, inner is negative 15x, so that's negative 18x, and then negative 3 times negative 3 is positive 9. Does that match? 5x squared minus 18x plus 9, it matches. That means my binomials are good. All right, 4x squared minus 15x minus 25. I do not see a common factor. I do see some perfect squares, right? So let me just see if it's a perfect square trinomial. 4x squared is a perfect square, 25 is a perfect square, half of 4x squared is 2x, or sorry, not half of, excuse me, square root of 4x squared is 2x, square root of 25 is 5, so 2x times 5 would be 10x, and 10x doubled would be 20x. So that center term doesn't work out. It's not a perfect square trinomial. That would have been nice, but no. Instead, I have A is 4, B is negative 15, C is negative 25, and AC is negative 100. What two numbers multiply to give me negative 100, but add to give me negative 15? And so let's see. 20 times 5 it's going to be. So I'll keep negative 20 and positive 5. Negative 20 times 5 is negative 100. Negative 20 plus 5 is negative 15. I know my top left is going to be my leading whole term. My bottom right is going to be my last term, including the negative. And I'm going to put in negative 20x and 5x. I'll pull out my common factors. So looking down, I can pull 4x. Looking down, I can pull 5. Left to right, the only thing I can get out of there is x. Left to right, I'm looking into a negative, so it has to be negative. And I'm going to pull a 5. Okay, let's double check that that worked. 4x plus 5 times x minus 5. I'm going to say 4x times x is 4x squared Outer is negative 20x, inner is 5x, so that's negative 15x, and last is negative 25. Is that what I wanted? 4x squared minus 15x minus 25. Check. Okay. So definitely try some of these on your own. Put the video on pause, try them on your own, because you want to make sure, it's really easy to follow along and be like, yeah, that makes sense. But you want to make sure you can do these on your own too. Okay, 2x squared plus 7x plus 6. I do not see any common factors. I have 2, 7, 6, 12. A times c is 12. What two numbers multiply to give me 12, but add to give me 7? Well, 4 times 3. How about that? So I'm going to fill in my box now. And over here, I put my top left is going to be the first whole term, 2x squared. Bottom right is going to be 6. Okay, and then I'm going to fill in with 4x and 3x. Again, remember, 4x plus 3x equals 7x. That's where we got that. Okay, so looking down, I'm going to pull 2x out of these two numbers, 2x squared and 4x. I'm going to pull a 3 out of there. Left to right, I can get an x. Left to right, I can get a 2. So I should be 2x plus 3 times x plus 2. All right, when I multiply to check, 2x times x is 2x squared. Outer is 4x, inner is 3x, so my combined is 7x. And last is 6, and I'm double checking, and 2x squared plus 7x plus 6 is correct. That means I found the binomials I wanted. Again, if you go and check your work and it's close and it's just not working and you feel like you did everything right, always go back and look and see if there was a common factor that you forgot to pull out. Okay, 2x squared minus 11x minus 6. I don't see anything to pull as a common factor, so I'm going to say a is 2, b is negative 11, c is negative 6, a times c is negative 12. What multiplies to give me negative 12 but adds to give me negative 11? Negative 12 and positive 1, right? Negative 12 plus 1 is negative 11. Those are my magic numbers that go in my diagonals. My top left is 2x squared, and my bottom right is negative 6. Don't lose your negatives. I'm going to plug in negative 12x and x. So when I look down here, I can pull out 2x. When I look down here, I can't pull anything except for a 1, but I need to put something. I can't just leave it blank, okay? Left to right, I can get an x out of there. Left to right here, I'm looking into a negative box, so I have to pull a negative. And it looks like I can take a negative 6. 2x plus 1 times x minus 6. So let's just be sure. When I multiply 2x times x, I get 2x squared. Outer is negative 12x. Inner is x, so that's negative 11x. Last is negative 6. 2x squared minus 11x minus 6. Okay. All right. Now this time, just for the purposes of looking at this video, I have given you a reminder that you want to check for a greatest common factor first. Always do that. 28x squared plus 28xy minus 56. Well, I think I can take 28 out. But that's it. So I'm going to say this is all 28 times x squared plus xy minus 2y squared. Does that make sense? Okay. So my answer, and it's not a bad idea to go ahead and do this, right? You know it's going to be 28 times your two binomials, if you can break it up into two binomials. Sometimes it's prime and you can't get this, but sometimes I'll do this just so I'm not going to lose that 28, because that is part of the answer, right? Now I'm going to factor x squared plus xy minus 2y squared. I'm going to factor it. Oh, and actually, you know what? It's just a leading coefficient of 1, so I'm probably not going to use my box. So, I'll erase my box. I could, but it's just kind of extra math if I do that. Okay, so I know that I need two numbers that multiply to give me negative 2, but they have to add to give me 1. Okay, and so that's going to be 2 times negative 1, right? 2 times negative 1 is negative 2. 2 minus 1 is 1. Since I have more than one variable, most of the time I'm just going to write this, I'm going to factor by grouping. It just is more logical to me about how to figure out where those other variables go. So I'm going to write this as x squared plus 2x xy, sorry, minus xy minus 2y squared. I broke up xy into 2xy minus xy. Then I look at my first two terms and I pull out an x. So I have x times x plus 2y. And then I'm going to pull out a y from these guys, a negative y, and I'm left with x plus 2y. There's my matching binomial, so I'm going to have x plus 2y here, and I'm left with x minus y. Okay, that was just me factoring the trinomial that I was left with. I still have 28 as part of my answer. So my answer is going to be x plus 2y times x minus y up here. 28 times x plus 2y times x minus y. If I want to double check, x times x is x squared. Outer is negative xy, inner is 2xy, so 2xy minus xy is just xy, and then last is negative 2y squared. Okay, then, so that's true, right? That matches the trinomial I expected. And if I want to really double check that I got everything right, 28x squared plus 28xy minus 56y squared, I would multiply that 28 back through. Okay, 8x cubed minus 16x squared plus 6x. I can pull 2 out of each of those coefficients, and I can take the variable x out. So I'm going to say 2x out of there. I'm left with 4x squared minus 8x plus 3. Okay, so if you want to start your answer now, you can. Of course, I'm going to be out of room there. So I'm just going to factor just the trinomial right now. And my leading coefficient is greater than 1, so I'm going to use a box this time. Right, I'm going to use a box. I know 4x squared goes in the top left, 3 goes in the bottom right, and I've got to figure out my b's, my two corners. So I know I need two numbers that multiply to give me 12, but when I add them together, they give me negative 8. So how about negative 2 and negative 6? Negative 2 times negative 6 is 12. Negative 2 plus negative 6 is negative 8. So I'm going to say negative 2x and negative 6x. All right, looking down, I can pull 2x. Looking down, I can pull negative 3. When you're looking into the box that's negative, you have to pull a negative out. Left to right here, I'm going to say that's 2x, and left to right here, negative 1 is the only thing I can get. Okay, so I know my answers 2x minus 3 and 2x minus 1. That whole thing is my answer, right? But let's just double check and make sure at least I got my binomials right. 2x times 2x is 4x squared. Outer is negative 6x, inner is negative 2x, so that's negative 8x. And last is positive 3. That matches my trinomial. And if I multiply that 2x back inside, I get 8x cubed, yes, negative 16x squared, and 6x. Okay. All right, so we're going to say that the area of a rectangular kitchen tile is all of this, 15x squared minus 14x minus 8. The length is 5x squared. I'm sorry, that's not it. The length is 5x plus 2, and what would the width be? You know, area of a rectangle is length times width. So we know our area is 15x squared minus 14x minus 8. That's our area, because they told us, right, area. It equals length times width. So it's going to be 5x plus 2 times whatever the width is. Well, you guys, we can figure this out, right? Because I know I'm going to multiply my first two terms, 5x times something, to get 15x squared. Well, the only thing I can do is 3x, right? So I'm just going to logic my way through this. 5x times 3x is 15x squared. Does that work? I know my last two numbers have to multiply to give me negative 8. So 2 times negative 4 gives me negative 8. This is probably it, right? But let me just triple check. I'm going to multiply these binomials to make sure that what I found is the correct answer, okay? 5x times 3x is 15x squared. Outer is negative 20x, inner is 16x, so negative 20, I lied, 6x. Negative 20 and 6 is negative 14x. And last would be negative 8. So I double checked my answer, and that means that this must be the width right here in this box, right? All right, thanks so much for watching. I know you can hear all the chairs. That means that we've got students heading in any second. So I'm glad you watched, and look forward to the next video.